My name is Erdem Günay. I work as a principal engineer at Turkcell. Today, I will try to share what we have done in one of our most recent projects, where we have used Reactive Spring Stack for replatforming, rewriting one of our legacy applications that was not performing very well. We were not happy with it. And by using Reactive Spring Stack, Reactive Redis, Reactive Kafka, we have come up with a brand new application, which is performing quite well since March this year. I'm gonna go over slightly what we have done there. I have got a couple of slides to share, and then I will make a demonstration of the application from production, real time. And then I will dive into some pieces of code to show you what we have done, basically, how we have used the Reactive Spring Stack. Does anybody remember this slide from Tuesday, the first day's main stage keynote from Leah? This is basically why I am here, because I like sharing what I know, what I learn, what I do, what I gain. And it was really like reflecting my feelings, what she has said. With these similar feelings, the same feelings, I have initiated a Spring Meetup group in Istanbul almost 3 years ago. And we are now like 4,300 members. And we have been organizing sessions on Spring technologies, Spring Stack, in Istanbul and in Barcelona, in Kingston. We also organized twice Spring One Tour activity in Istanbul, where we had 300 plus attendees, local attendees in the Spring One Tour. Just a few words on my company. Turkcell is a telecom operator, mobile operator, the biggest one in Turkey, but having a vision on transforming to digital world, transforming to digital services. We have messaging application, we have TV, live and on-demand TV service, we have music platform, and we have online magazine platform, and there are others. In total, we have 50 million users in the countries where we operate. The scope of this session will be, as I said, a demonstration of streaming features in our brand new application. It's going to be a live coding on Reactive Spring Redis. We will do simple things, but that will reflect, believe me, that will reflect what we have done all in the project to come up with this brand new application. I will also write some code for streaming events through Kafka using Reactive Spring. But it's not going to be a deep dive into Reactive Stack, Kafka, Redis, and I'm going to share at the end, in my last slide, related sessions that has happened so far, that has been shared in the conference. There are 12 related sessions where you can follow and you can go into details of these topics, and we only have 30 minutes. So what we have done in the project is we are streaming live real-time data of 200 tournaments, football tournaments of 3,500 teams from many different countries. With the project, we have managed to send occurred push notifications to our users. Before we did it, one of our users could possibly get the push notification of 3-1 score before 0-1. So that wasn't really nice and in good situation, in good shape. And now with all these engineering, re-platforming, when a goal is scored, before the ball is even taken out of the goal, we can deliver the push notifications to the users. That's a really big gain, big change. Out of only 4 virtual VMs, not too much capacity, we can easily reach 1 million concurrent users for streaming real time data. Before, it wasn't really bad. It was really bad. Every now and then, especially in the big games, we would have crash in the platform. No more crashes. As I said, this is not comparable to how it was, what it was before. And we can deliver more frequently. Okay, now it's time for the demo. I'm going to show you the application, and I'm going to show you the streaming features of the application. Okay, this is the application. We have news, we have live score information, where we deliver the score changes, as I said. If I click on this button, I will be locating to only those active games that's currently being played. Before, this client would poll every now and then, every 3 seconds, every 5 seconds, and it would require something like 400, 500K kilobytes of data for each request, and that would cause the crash, obviously. What I will do now, I will connect to the production server, just like this application. Now I have two streaming connections to the production servers. As you can see, the data is being sent only if there is a change in one of the games. And this application, mobile application here, it will get the result from the change, very few bytes of data, and it will reflect the change on the mobile application. That's basically how we could manage to solve those problems. If I go to one of the applications here, one of the games, that's already finished, I will be able to see the events here as well. This is no more streaming because the game is over. There is no make sense to stream here again. And one more demonstration is here. It's the same infrastructure. I'm connected to the server with another streaming connection, streaming socket, where I will be listening to the comments. That is, this is kind of a chat room. You can think about it. I will open the application here and go to the same game. I will write a message, and I should see it on both application and the console. And that's going to be the end of the demo. Okay, I'm connected to the same page here. Hi from Spring 1. We should be able to see the message coming here. This is my message, and the same message is streamed here as well. Hi from Spring 1. This is the end of the demo. Now I should go to show you and implement it together with you how we did it, how we used the Spring Stack. Oh, before going into that part, I'm going to show you one more thing, which is, all right, it should be there. I have got two repositories in my GitHub account. One of them is, the first one is the project of today's session, which focuses only on Reactive Redis and Reactive Kafka. But I also had the chance to share this project in Barcelona in Spring IO 19 as well, where I had the chance to do this in 2 hours. That was a workshop. I had a lot of time, so I could go into details of other features that we used in the project, like Cloud Contract and Cloud Config, Service Registry, Gateway stuff. The second project is going to be the kind of full set of being cloud-native reactive application. You can refer to these repositories. Now it's time for coding. Okay, what makes an application reactive? I'm sure you have seen this, right? Who has seen a reactive application, has implemented a reactive application? Okay, not that many. Okay, so I'll just briefly go over it. It's Spring Boot application. No changes there. We use Spring Boot Starter parent again. But this time, if you want to have a reactive web application, you need to use Spring Boot Starter WebFlux, not the Spring Boot Starter Web. This is going to boot a NetE server where your application will be running in a non-blocking fashion, in a reactive fashion. If you want to use Redis in a reactive way, you need to include starter data Redis reactive dependency. And similarly, I will use Spring Kafka and Reactive Kafka dependencies for accessing Kafka in a reactive manner so that I can stream the changes, the events to my clients. There are a couple of configurations here for Redis and for Kafka. I'm not going to go into too much details. I don't want to lose time there. But just to mention, what I need is a connection factory, Lettuce, supporting reactive stack, and a Reactive Redis template for storing, saving match entities, and querying them. I'm going to need it. I'm going to need some serializer, but you can go over it yourselves. Currently, the application does not do much. I have the basics. I have controller. I have mappings. I didn't want to spend time on here, but my REST controller endpoints do not actually return anything. For example, this streaming part is just returning an empty Flux, empty stream. I'm not going to see anything. And this finding the entities from Redis and persisting the content, the data in Redis is also empty. What I'm gonna do today is I'm gonna implement this part so that you can have an idea on how you can use Reactive Spring. Let me run this application. Once I need to check if my Redis is running. Yes, my Kafka's Zookeeper is running. Everything seems to be fine. When I run the application, my demo scope will be, I will query the matches with ID 1, which currently does not return anything because there is no implementation. I will save the data of a change of a game, which also doesn't do anything. And what I will also do is I will start a stream for following the match with ID 1. But it doesn't do anything because it's an empty Flux, so it opens and closes immediately. I need to implement code here now. Let me first start with Redis. I also show you what I have here in Redis. I will delete matches. I should have nothing here. And then I will start persisting data in Redis. All it takes is the template you remember I showed you. Using the template, I get a hash operations object reactively, and then I will put this data in this key, which is matches, the name of the collection, and then the hash key of the data that I persist in Redis, which is matches IDs in string, and the match object, match entity itself. Currently, this mono is returning me a Boolean, like saying that Redis was successful or not, true, successful, false, not successful. It's not like that, but I don't go into there. Even if it's false, it does update your data. I don't know how, why. All I need to do is I want to change the scenario just to show you how we play with the Flux and mono streams. What I get from Redis is a Boolean. But what I want to return is OK, not OK, OK, knock. You know, it's a silly business, but still can be business. What I will do, if this Boolean is true, I will return OK. If not, I will return not OK. I should be fine. I'm restarting. Normally, I have dev tools that should do hot deployment, but I think there is a little thing with the Kafka, so I will keep on the safe side for the sake of demo. And I will do restart. Now if I go and submit again, if I post the match information again, I see OK here, and I should see my data being populated in Redis. You see 1, hget matches 1. I see the data that I have posted serialized in a JSON format, JSON data format, and persisted in Redis, and I get the response back. What happened here is when I called this put method, it's not blocking anymore. Until it leaves the I/O layer of my application, the thread will be will not be with my thing anymore, my work anymore. And as soon as Redis returns with the response, possibly another thread will take the job and continue processing from this moment on with the mapping. Okay, so let's see if we can also get it. We can query it from Redis. It's the same hash operations, but this time get from this key matches with the hash key ID converted to the string representation. Let me restart and see if we can get our data back with this get query. I'm gonna querying for the match with the ID 1. It's a bit small, but there's nothing much than this actually. Okay, now I can query match item with ID 1. If I look for 2, it will just return nothing because it's a mono stream with no item in it, an empty item because there is no data. The Redis part is this much. I mean, you can obviously add other functionalities, other features if you need, but this is mainly what we have done. So simple, that simple. We store a lot of information in Redis because we use Redis as our main data store, considering the performance. And it's basically this much of information, this much of things we have done. Now I should go to finish my hands-on coding. I should look at this part because I try to start a stream between my client and my server application, but it doesn't do anything. It just opens and closes a stream. So what I have to do, I have to work on my controller here, which is returning an empty Flux. Instead of returning an empty Flux, what I will do, I will connect to a Kafka receiver, and then I will start getting the events which are pushed to Kafka topic here, and then I will play with it because I get a raw string from Kafka. I need to play with it. I need to convert it to match entities. I need to do some controls, some checks, because I should not deliver all the information to all the clients. Because, for example, in my demo, I was looking at only one match, only one day, only one topic. It doesn't make sense to send to my client all the information, all the data. That would result in problems. So I need to make sure that I'm doing the right thing. To begin with, what I will do, I will first get event publisher, which will return me, let's see what it will return to me. It will return me a connectable Flux of server sent event of string. As I said, it's simple to use string while communicating with Kafka. But this connectable Flux has a special feature. I could not use Kafka receiver.receive, which is also returning me a Flux. You can connect to this Flux only once. That's why I wrap that stream in a connectable Flux so that I can open as many requests as that come from my clients, maybe 10,000, maybe 1 million. So connectable Flux is the key term here. You need to change this Flux, Kafka receiver's Flux to a connectable Flux. So what I have here, I have got a string of server sent event. But what I want to do, I want to convert this to a match object because I'm dealing with match objects. So what I will do, match JSON string to match, which is string server sent events, data, payload, body. That has been arrived from Kafka. It is arrived from Kafka. Now what I have, I converted the Flux, the entities in Flux to different type. It was server sent events, now it's matches. So what I have to do, I also have to convert this match back to a server sent event of matches because that's my promise, that's my contract. I said I'm gonna return server sent event of matches. So what I do, match to server sent event, match. I could make it simple, this 2 semicolon and then the name of the method, I could do it. But now seems fine. I should be able to see something going on. At least my clients should be able to keep connected because it's not an empty stream anymore. It's a stream which will be kept alive as long as one of the sites does not kill the session, does not kill the connection. Okay, I have it, but let's see if I will be able to get the data streamed to this client. I'm posting again with the ID 1, but probably I will not see anything because I didn't bind the event to Kafka. I didn't put it in the topic of the Kafka. I'm gonna do it now, which is again the service in the save match details, right? Just after putting the content, the data in the Redis, what I will do, I will also put the content, send the event to Kafka. For this, I will use Kafka sender.send, which will expect me a stream publisher. That can be a mono, that can be Flux. Mono means I will send only one item. Flux means I might send more than one items to Kafka, which is our match object. And then once we do this, we get back, what do we get? We get back a flux of responses, Kafka results. So what I will do, since I know I sent one item, I can say that I'm interested in the next item because I'm sure there is nothing else. And what I have now, I have here a sender result, what happened to my request to Kafka, and I need to convert it to Boolean because here my promise is I want to stick with Redis's return type. I want to generate a true or false to indicate that this was a successful or not successful operation. What I do, tsender result.exception, if it is null, to me, it's my business. It might not be the best, the most true thing in the world, but to me it's like this. And then I will return this. I will return flat map. Okay, I should put these things. Mono.just match Kafka sender. Let's not try to understand too much. Let's just try to use it here. Kafka sender.send, mono.just. Oh yeah, match to sender record. I missed this part because I cannot just send a match item. I need to wrap it in a sender record. That's what was required actually. I have only 3 minutes left. Let's restart. Should be fine. We will see. All right, again, streaming for item ID is 1. And let's post it again. Yeah, there it is. We have we are notified with the events, with the delta information of this game with ID 1. But now I'm gonna challenge myself. I still have 2 more minutes. I can do that. This one should not get it right because I'm watching the match with ID 2. I should not get it. So what I do another iteration of my application, and here, when I get the match, I'm gonna do a filtering because all of the events pass through this Flux here. I need to filter out some of them which are not relevant. So here, what do I have? Match, and then I need to check if the match's ID is equal to the argument ID here that is passed to my RESTful method here. Okay, let's restart. Should be fine. I guess I will have half a minute left. Again, since the application server has restarted, connections are lost. This one is 1, this one is 2, and now if I send it, this one doesn't get, this one has it. I send item 2 just to make sure that everything is working fine. If I send 3, nobody gets it, right? Should get it. Okay, this one doesn't. This one doesn't. That's, I think, pretty much all I wanted to share with you. I hope you enjoyed. I hope you find it useful and it helps